Okay, can you hear me now?
Yes, sir.
Good. My AirPods, first of all, they weren't working right, and then they finally started to connect, and then the microphone wouldn't work. Okay. See if I can get our notes from last time pulled up. There we go. If I can get logged into our Google Meet from my iPad. Just a moment here. Right, now I've been able to get into the meeting, and we will share my screen from my iPad. Okay. Can everyone see my screen okay?
Yes, sir.
Very good. All right. Let's see if I can get on my other screen. Now, you probably have seen in the main course that I have posted the solutions for all of these questions for the review. You should be able to see those now. But we will go through as many of these as we can today. And first, I want you to spend just a few minutes working on number 13. We had done number 12 last time. Pencil here. Like I said, we did number 12 last time. Make that solution small enough that it fits. So work for just a few minutes on number 13, because that's a little more complicated. And then we'll come back and I'll work through that solution for you, and I will be back shortly. Okay, so let's get started. So we want to find the difference quotient, which is f of x plus h minus f of x all over h. So what we do to find that is we plug in x plus h first. So that's 4 times x plus h squared minus 5 times x plus h plus 2 minus just the original function 4x squared minus 5x plus 2 all over h. So that's our first step. In our next step, we need to expand out x plus h squared. So I'm still going to use my brackets. 4 times x plus h squared will give me x squared plus 2 times xh plus h squared. Oops. 4 times that minus 5x minus 5h plus 2. That's our first part. And I need to move up this. Let's see if I can move that over here just a bit. And then we have minus a 4x squared minus 5x plus 2. All over h. So we then can distribute the 4, and we get 4x squared plus 8xh plus 4h squared minus 5x minus 5h plus 2 minus a 4x squared minus 5x plus 2 all over h. And then we can combine all of the like terms. I have to shrink this down a little bit. I'm going to shrink the h too, but that's okay. So the x squared stuff, let's just do one rewrite where we distribute the negative here to each of those terms. And so we get 4x squared plus 8xh plus 4h squared minus 5x minus 5h plus 2. Running out of room here. Minus 4x squared over plus 5x minus 2 all over h. Okay, so we have a 4x squared minus a 4x squared, so those cancel. We have a minus 5x plus 5x, which cancels. We have a plus 2 minus 2, which cancels. And so we're left with 8xh plus 4h squared minus 5h all over h. Okay, so we can cancel h's out. So it'll cancel this one here, one of the h's here, and this one. So we get 8x plus 4h minus 5, which would be your final answer. I know that's a lot of steps, a lot of distributing to get to that final answer. questions about that one? Okay,
no, sir.
Let's move on and discuss these little functions in 14, 15, and 16. So the question first is number 14 a function? Well,
No.
there's not a vertical line that I can pass through that would pass through it more than once. So anywhere I put a vertical line, it only crosses the graph once. So yes, this is a function. The domain, let's clean up our graph here. Because this arrow goes down forever and this arrow goes down forever, it's getting a little bit wider as it goes down. So our domain on this one is negative infinity to positive infinity. Our range, on the other hand, if you look at it, there are no values that are above 3. Okay, 3 is included, but 3 is the biggest number we can have. So it keeps going down forever, so it goes down to negative infinity and up at most to 3. Okay. And then we want to look for increasing and decreasing. Well, in what parts of the graph are we going up from left to right? Well, it looks like from negative infinity up, 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 up until we get to x equals -4. So we're increasing from negative infinity up to 4, not 4, -4. And then we decrease from 4 to infinity. We're always decreasing from there. So from -4 to infinity. Are there any places where this graph is constant, where it's just a straight line? Well, no. So there are none. Okay, on this next one, this nice little reverse S-shaped graph, is this a function? Well, there are no vertical lines that I can go through there that would cross it more than once. So yes, this is a function. Again, from left to right, the domain x goes off to negative infinity, and then we go to the right and it keeps going. So all the x values from negative infinity to positive infinity are possible. Domain values, range, same thing. We're going up, not very quickly, but we are going up, and we're going down in this direction. So our range will also be negative infinity to positive infinity, the y values. So from left to right, are there any areas, any intervals of increase? Well, it looks like if I jump on this roller coaster from the left, any way you look at it, we're going down, down, down the whole way from negative infinity to positive infinity. So there are no intervals of increasing. Oops. Hang on just a second. For whatever reason, I got kicked out. Well, that is super strange. Let's try that again. Okay, the app decided to update while we were using it. Weird. Okay, decreasing. We're decreasing from negative infinity to positive infinity. And constant, again, there are none. All right, number 16. Is that a function?
No.
And it's not a function because if we draw a vertical line right there, we cross it twice. So this is not a function. Okay. Its domain, the x values, if you look very closely, it starts at x equals -3, and then goes on to the right forever. So our domain is from, looks like it actually includes -3, so we need a bracket, -3 to infinity. The range, if you look at this graph, it's extending, it's getting wider and wider. So that range will be -infinity to +infinity. And this point right here determines where the increasing and decreasing is. So it's increasing from -3 to infinity, but it's also decreasing from -3 to infinity on the same interval. Okay. Is it constant anywhere? No, so there are none. Any questions about those?
No, sir.
Okay. So number 17, we want to determine the domain for the function. What part of this function gives us a problem? Well, in a fraction, this bottom part cannot be 0. So we have to say that x plus 3 cannot equal 0. And we can solve that by subtracting 3, and we get x cannot be -3. So if you were to look for the domain there, the domain is all real numbers except -3, or in interval notation, -infinity to -3, union -3 to infinity. So all the values except that -3. Okay. On number 18, the thing that causes the problem would be inside the square root. The stuff inside a square root, for it to be a function, the x minus 5 has to be greater than or equal to 0. Cannot be negative. So we can add 5 to both sides, and we have that x is greater than or equal to 5. In interval notation, that domain is from 5 to infinity, including 5. So you have to have this bracket here. That has to be in there, because if you have 5 minus 5 is 0, you can take the square root of 0. That's perfectly legal. Okay. All right, let's move on and describe some transformations of functions. So on 19, the first thing I want to look in is on the very inside, this -1. That's a horizontal shift. And it's 1 unit. Which direction is it? Because it's inside the function. Is it right or left?
Left.
Well, you think that it's left because it's the minus. But because it's inside our function, inside the squaring function here, it's actually the opposite of what you would think. So it's a shift right. Okay? And then this coefficient outside the function says that we have a stretch, a vertical stretch of 4. Because there's no negative there, there's no negative, not no negative, but no reflection across the x-axis. And because there's not one inside, there's no reflection across the y-axis. And then this last constant at the end means that we have a vertical shift 7 units, which direction, up or down. Because it's outside the function, this is our function, the squaring function. Because it's outside,
down, right?
It's down. It does exactly what you think it would do. Okay, on number 20, the first thing I look at is the inside of the function there, where we have that +4. So we have a horizontal shift four units in which direction?
Left.
4 units left. We have a vertical compression. This value here of 1/2. And because we have this negative out front, we have an x-axis reflection. Because there's no negative on the inside of our function, there's no y-axis reflection.
Did you say that was a compression because it's a fraction?
Yes, because it's between 0 and 1. If it was a number greater than 1, then it's a stretch. And that's true when it's on the outside of the function. If it's on the inside of the function, then those phrases switch. It's a horizontal stretch if it's between 0 and 1, and it's a horizontal compression if it's more than 1. And then finally, we have a vertical shift six units in which direction, up or down?
Up.
Up. Very good. Okay. Let's move on and look at number 21. Well, I guess really 21 through 26. We're looking at 6 different operations on functions. F plus g of x means that we just take those functions and add them together. So that's f of x plus g of x, which is x squared plus 3 plus 4x plus 1. We collect those like terms to get x squared 3, let's see. We have 4x, just one linear term, and then we have 3 plus 1, which is 4. Similarly, f minus g of x is f of x minus g of x. So we have x squared plus 3 minus 4x plus 1, which is x squared plus 3 minus 4x minus 1, which gives us x squared minus 4x, and 3 minus 1 is plus 2. Again, we distributed that negative. That's why we got the negative 4x and the negative 1 out of this. What about f times g of x? Well, that's f of x times g of x, which is x squared plus 3 times 4x plus 1. And so we use the distributive property and double distribute. So we get x squared oops, not x squared. We get x squared times 4x, which is 4x cubed. And then we get x squared times 1 plus x squared. And then we move to the second term and do 3 times 4x, which is plus 12x, and 3 times 1, which is 3. And there's no combining of like terms there, so we leave that the way it is. What about f divided by g of x? Well, that's f of x divided by g of x. This will probably be your favorite one because you get x squared plus 3 over 4x plus 1. And neither of those can be factored, so it can't be simplified any further. Now these, the next two, are probably your least favorites because FOG, f composed with g of x, means that we take f and our input for f is the whole function g of x, which is the same as saying f of 4x plus 1 or 4x plus 1 quantity squared plus 3. Okay, when we double distribute, make this a little bit smaller. When I double distribute 4x plus 1 squared, I get 4x squared, 16, 4 times 4, so 16x squared plus 8x plus 1 plus 3, which is just 16x squared plus 8x plus 4. And the way we get this, the 4x plus 1 squared, is we double distribute. And then finally, GOF, G composed with F, is G of f of x, which is G of x squared plus 3, or 4 times x squared plus 3 plus 1. We can distribute that 4 to get 4x squared. 4 times 3 is 12, and 4 times 1 is 4. Oh, no. You don't distribute that 4. I thought I saw the parentheses there. This is your answer. 4 times x squared and 4 times 3. And then the 1 is just a separate term. So 4x squared plus 12 plus 1, which is 4x squared plus 13. There we go. That's what happens when I try and get in a hurry so we can get all these problems in. Any questions about operations with functions and composition of functions? Okay. So now we want to use the graphs to perform the indicated operations. We want to find f plus g of 2. Okay. So what we're looking for is f of 2 plus g of 2. Well, f of 2 is this function f evaluated at 2. So we look right here. That's 2 on the x-axis. And we get out a -3. So that's equal to -3. And g of 2, when I evaluate at 2, I get 6. So that's -3 plus 6, which is equal to 3. Okay, so now we want to find f times g, not FOG, but f times g of 0. So that's f of 0 plus g of 0. Well, we can evaluate f at 0 when x is 0. F is 2. And when g is 0, when x is 0, g is 4. So we have, wait a second, it looks like I messed up that first one. When x is 0, it looks like f is 1. And then g is 4. I'm just driving the struggle bus today. We're looking at f times g, not f plus g. There we go. 1 times 4, which is just 4. Okay, I'll get this one right. I will slow down so I can get f composed with g of -2. That's f of g of -2. So we need to find g of -2. So I look at the function g and I want to evaluate it at -2. That looks like it's 2. Okay? So we're looking at f of 2. So now we need to evaluate f when f is 2, which is -3. That's f og of -2 is -3. Okay. Now we want to do the same sorts of things, except now we're using a table instead of graphs. So we want to find f minus g of 4. So that's the same thing as f of 4 minus g of 4. So f of 4, when x is 4, f is 2. And when x is 4, g is 3. So 2 minus 3, or -1. Okay. F divided by g of 1 is the same as f of 1 divided by g of 1. Well, f of 1, f evaluated at 1 is 4. And g evaluated at 1 is 2. So we have 4 over 2, and 4 over 2 is just 2. Last one is a composition. Compositions are a little more complicated. So we're looking at g of f of 3. So we're first evaluating f of 3. So when we look at x equals 3, f is 2. So we're evaluating g of 2. Okay. So when x is 2, g is 4.
Those seem so complicated until you're actually working it out, and then it's easy.
Well, and compositions, just the way they look, are more complicated. And then if you just follow your nose through the problem, it's not as bad as you think it is. That is, of course, until you get to evaluating a piecewise function. And I know we've done a few of these in this in the COREC, but I do want to do this one so we have a little extra practice. So again, we're evaluating the function on different pieces of its domain. So if x is less than or equal to 3, the function is this part. If x is between 3 and 6 and equal to 6, it's this part. Anything greater than 6, it's this part. So f of -2. Which piece are we looking at?
The first one, 3x plus 2.
We're looking at 3x plus 2 because negative 2 is less than or equal to 3. So we're looking at 3 times negative 2 plus 2, which is 3 times negative 2 is negative 6, plus 2 is equal to negative 4. Okay. F of 8. Well, 8 is greater than 6, so we just multiply it by 6. So 6x is the part we're using. So 6 times 8 is 48. What about f of 3? Which part do we use?
The first one again.
We use the first one because it's equal to 3. So 3 times 3 plus 2. 3 times 3 is 9, plus 2 is 11. And finally, f of 6, which one do we use?
The second one.
We use the second one because it's equal to 6. So we have 6 squared minus 1. What's 6 squared? 36.
36.
36 minus 1 is 35.
35.
I think we may actually have time to finish these. We may go a little bit over, but I'll make sure we get through all of them. Okay, so we want to check to see if these functions are even, odd, or neither. Okay, so how do we do that? Well,
I'm sorry.
Go ahead.
I have a question on that, of the 30 and 31. I seen where they were just looking at the exponents. Is that what you want us to do? Or do you want us to write everything out?
So if you just look at the exponents, you won't always get the right answer. And I don't have a counterexample to show you, but let's take a look at f of negative x. Because that's really what we're testing. So what is f of negative x? Well, I get 4 times negative 4, not negative 4, negative x to the 4th minus 2 times negative x squared plus 3. I need to rewrite this exponent so it doesn't look like it's a 4 times. Okay, what is negative x to the 4th? Well, negative x to the 4th is just x to the 4th. It becomes positive because we have an even number of factors of negative x. So if you have an even number of negatives, it becomes positive. Negative 2 times negative x squared. Well, negative x squared, same story, becomes x squared. So we have negative 2x squared plus 3. So is that exactly the same as what we started as?
Yeah.
So since f of x is equal to f of negative x, f of x is even. So if you get the same thing, you get an even function. Let's do the same thing for number 31. Let's see if it's even. So f of negative x is equal to negative 3 times negative x to the 5th plus negative x to the 3rd. Okay. And what we get is negative 3 times a negative x to the 5th. So we get 3x to the 5th. And negative x cubed is going to give us also a negative, and we'll get x cubed. So is that the same as what we started with?
No, because the x is negative. It's minus
Yes.
x cubed instead of.
So minus x plus x cubed, minus 3x to the fifth plus x cubed. And this one we have positive 3x to the fifth minus x cubed. So since f of negative x is the opposite of f of x is odd. So in other words, if we had multiplied negative f of x, negative f of negative x, we would have gotten the original function. That's what tells us this is odd.
Question, how did that
Oh,
negative 3 become that 3?
because when we multiply out this x to the fifth, negative x to the fifth, you get negative x to the fifth power. And a negative times a negative is a positive. Does that make sense?
Yes.
Perfect. All right. Last ones. So we first want to find the inverse of x squared plus 3. Well, that means we can start out with y is equal to x squared plus 3. If we want to find the inverse, we switch the x and y and then solve for y. So we just switch them out. So x is equal to y squared plus 3. Then we can subtract 3 from both sides, and we get x minus 3 is equal to y squared. How do we get y by itself?
We square both sides.
Well, we take the square root of both sides. That's how you undo the squaring. So we have it squared, so to undo that, you take the square root. So what we get is y is equal to the square root of x minus 3. So f inverse of x equal to the square root of x minus 3. Okay? And how do we find the domain? Well, what thing will cause a problem for our domain for this new inverse function?
Is this where it can't be equal to 0? Or it has to be greater than or equal to 0?
Yes, because we're dealing with the square root. We can't take the square root of a negative number in functions. So x minus 3 has to be greater than or equal to 0. We can add 3 to both sides, and we find that x is greater than or equal to 3. So our domain is from 3 to infinity. Okay. Last one. We start out with x plus 3 to the 1/3 power minus 2. So let's just put in a y in for f of x just for ease of operation. Then we can switch those out. And we say x is equal to y plus 3 to the 1/3 minus 2. And what is something raised to the 1/3 power? What does that really mean? Well, when we're dealing with rational exponents, that bottom number is the index of the root. So we're taking the third root, or the cube root, of y plus 3 minus 2. So we're trying to solve for y, so we have to move this 2 to the other side, and we get x plus 2 is equal to the cube root of y plus 3. Okay? how do we undo the cube root?
You do the same thing on the other side. Take the cube root.
Well, we have the cube root. We want to get rid of it. We want to do the opposite. What's the inverse of the cube root?
Cube.
We have to raise it to what power?
3.
To the third.
We have to raise both sides to the third power. So what we get on the left side is x plus 2 just to the third power. And on the right side, this cube cancels out this cube root, because what we effectively have is y plus 3 to the 3 over 3 power, or y plus 3. Then we can subtract 3 from both sides, and we get y is equal to x plus 2 quantity cubed minus 3. So f inverse of x is equal to x plus 2 cubed minus 3. So what real numbers can I add the number 2 to? Is there any real number that I can't add 2 to it?
No.
No, you can add 2 to any number you want to. Is there any number that you can't multiply by itself 3 times?
No.
No. So our domain is negative infinity to positive infinity. There are no restrictions. Okay, that is all of the questions we have on the review. I'm happy to stay around for a few minutes and answer any questions you have, but that ends the formal part of this co-requisite. Remember, your exam is due by midnight tomorrow, and I have given you additional time on this exam. I know some of you got cut off last time. That will not happen this time. You should have 3 hours to complete it. All right, well, if there are no questions, we'll end it there, and I will post this video as soon as it gets processed by Google, and I'll share it back, and then I'll share my notes on what we did on the screen as well.
Thank you.
Thank you all. Good luck on your test.
Thank you.